A feature that we are planning that is not yet part of the CTP or the service, but eventually will be, is to run instances redundantly. And this is just corresponding to Windows Azure hosted services, where you can say, I want to run that role on 2 or more instances, just to get some SLA for Azure. Well, of course, we need to do the same thing to eventually make outages really transparent. And that's one of the design goals that we're currently working on. I mentioned the spooling, the ability to record the raw incoming event stream to storage, and then use that for later offline processing, backtesting, auditing. And the Azure integration is another very central design goal for us. Consists of showing up in the Azure Management Portal, being part of that Azure ecosystem of services, being able to easily combine and couple the experience of Azure StreamInsight with, for instance, SQL Azure by seamlessly persisting the streaming results into a database or into Azure storage, and of course be integrated into the billing experience, showing up on the bill, and make sure that I have a consistent view of everything I do in Azure, including the StreamInsight service. All right, I actually want to run a demo. I only showed code so far. Just before I started the presentation, I noticed it was not running. So let me see whether I'm lucky now and my demo is running. What the demo is doing is it uses tags. I just brought up, and I hope you can see my desktop. I brought up a Microsoft tag, which, if you scan that with your cell phone, creates a call to a URL. And I'm using that as my data source with my cell phone, and you, if you want to use it, representing data sources that send data to that URL, which then gets processed. It's the HTTP endpoint of an Austin service, in fact. And so the events are processed within that service, and the results are streamed to 2 consumers. One consumer is a map that's supposed to show where those tags have been scanned, provided you enables the location feature of your, if that's a Windows phone, of the search application. And the other consumer is simply counting of user agents, depending on what agents you use, whether it's a Windows phone or something else that uses not Internet Explorer. And I can reason over that, and I can aggregate that in StreamInsight and then display that on a web page. So actually, let me try it first with my own cell phone, seeing whether it actually works now. Calling out to the URL, which should cause the HTTP endpoints to be called. Yeah, I think it did. You see that the count updated, and the count is within the last 10 minutes. So the other results didn't update because there was nothing updating the account. But the IE mobile just shows my own scan. And if you want, I can leave that page open for a while and talk about it while you are hopefully able to scan that tag with your cell phones on your screen. Again, if you have the location enabled, which is not enabled by default, you should actually show up on the map, depending on where you are. And I'm assuming somewhere in the US for most of you. If not, we can zoom out. And you should also see the user agent counts being updated. So I want to leave that open for a while. And while you're trying to do that, oh, okay, somebody else scanned apparently. So IE mobile went up to 2. So there's some success here. That might have been, oh, and I even get locations that are neither in Seattle nor in the Atlantic, which is the default for, latitude and longitude 0. So you see something's happening here. What is actually very remarkable is that it's pretty fast. It involves a lot of moving parts. There was Safari. There's an iPhone user out there apparently. There's a lot of moving parts. And scanning the tag, something that takes 1 to 2 seconds for the whole round trip. And this is actually pretty remarkable, not just regarding StreamInsight, but all the other parts that are involved here in terms of cloud services. There's service bus involved, there is Azure storage involved, and I'm going to walk through that. Just shows as a nice toy example that those tags can be used for something useful, or for something that gives you actually pretty interesting insights into user experience, which is the location, which is the user clients, and it could be much more than that. All right, so let me go back to the presentation here. Actually, before we do that, I have a tag simulator just to show you that this actually scales pretty well. This tag simulator is just sending random HTTP packets, or I shouldn't say random, but from random user agents and random locations, simulating hundreds of cell phone users scanning this tag across the country. So if I start that, that's what you would see. So you see things are really updating fast now. Also, the web page is pulling data from Azure storage. So the web page has a natural refresh frequency of 3 seconds, but the map that you see is, so that's the actual frequency of the query, producing results, pushing it over service bus to the map. And I provisioned that sample, that toy demo on, I think, one small ingress and one medium analytics. So it's really not using a lot of compute resources, and it could go way beyond that data rates. We are looking at data rates of several 10,000 per second. What I'm doing here is a handful per second at most. So it's really just showing the principle, not really giving a performance indication. All right, I will just let that run. And I will go back to the presentation to walk you through that use case, that end-to-end scenario of processing those tag events. Where are we? All right. So we are starting with phone scanning the tag, which creates an HTTP URI, a request to a URL. That's what it effectively does. If the location is enabled in the Windows Phone specifically, that's I think a Windows Phone feature, then as part of the URI, as a get string, with the question mark and then the key value pairs in the URI, also the location, latitude, longitude are included. What is also included with any HTTP request, naturally, by definition, is the user agent string, which is a fairly convoluted string, actually. So we get all that raw information to that URI. That's how I defined my tag. I registered this tag and defined it as going to this URI. So that's what happens first if you press the I and the scan on your phone. As soon as it goes into that URI, which is representing an Austin instance, we are within the, I should say StreamInsight Azure framework and pipeline. And first, as you've seen on the architecture before, we are in the ingress stage. So what happens in ingress stage, the way I defined it here, is I turned on a few things. First I turned on the spooling, so I persist all these packets. And then I do 2 transformations here. And that's what I defined in my sample, and that's what I let the cloud instance execute, is 2 transformations. One is taking the user agent string and translating that into something that's readable, like IE Mobile or Safari. The original string is something very convoluted, and it's not really clear what's the actual user agent. Luckily, there's a web service, so I'm actually calling out the web service, useragentstring.com. With every incoming event, I'm calling out to the web service, let it translate into a humanly consumable browser identification string, and take that and manage my events with that string. And at the same time, I'm also taking the latitude and longitude, taking the GPS position, and make a SQL Azure call as part of my ingress transformation. and transform that into a census block ID. I want to count the, you've seen on the map, you've seen that those are counts. That's the raw data. Those are counts, and they are actually associated with the census block. It's not just the location, because that would create way too many different labels. I want to aggregate that and group by bigger geographic areas, and I'm using census blocks for that. So I first map a geographic location. I just realized that I switched to the map without you seeing it, but you've seen the map with the labels, with the numbers, which are based on the counts within each census block. So I need to get the census block ID from that database based on the raw GPS location, and all of that is done in my ingress stage. And from there, I have enriched my event types. I have created more semantics, more meaning in my events, and I will use these additional properties that I derived in my actual query. And the StreamInsight query that's running here actually is twofold. There are two queries running on that stream. I multicast into two subqueries. Both are grouping. One is grouping by the browser and then counting. And you've seen the bars showing the number of user agent events within a certain time frame. I think it's 10 minutes or 5 minutes. And then I take that result. In this case, I put that into Azure Table Storage using an Azure Table sync in StreamInsight. And then on the other subquery, I group by census block and count there. So I'm counting the number of tags within a census block. And that I take and stream into a service bus endpoint, right? And now I have two event consumers, and the way I'm displaying the data is for the storage, I have created a very simple web page that does some regular calls against Azure Storage. It's an ASP.NET project, very simple, calling to Azure Table Storage, pulling that result and displaying it with a graph, with a bar chart. So that's pulling.